as I have shown you the videos, it gives us videos like this. See, this is very diluted one. We have a very less number of particles in that sample. Insert my solution into it. Okay, right now I was using it for cleaning purpose, but I'll just fix it in the instrument. And it has the microscope right up there to the setting. Okay, so it will just track everything live. Okay, right. Analysis और बेटा बता सकते हैं कि इसका बट आई क्या ऑन है अब वर्किंग है और इसमें क्या हो गया
Hello. So, welcome all in today's session on Bruker's Lumas 2 FTIR microscopy system for various applications. I am Dr. Vijay Veer. I am an application and product manager for FTIR spectrometers, then Raman spectrometers, gas analytic systems, and then remote sensing systems. So, as already my colleague introduced, Bruker is a German company, and see there are various different divisions which handles different analytical techniques. So here you can see Bruker Material, Bruker Biospin, Bruker Daltonics, Bruker Optics, and then Bruker Energy and Supercom Technologies, etc. So here we belong to Bruker Optic Division, and this is the head office of Bruker Optic Division in Ettlingen, Germany. So here you will find all all R&D, production, interest, then support, application development, logistic, everything you will find in this office. Now, as a Bruker Optics, we are the manufacturer of FTIR, FTNIR, then Raman spectrometers, microscopy systems, gas analytic systems, remote sensing systems. So we can use these systems in different fields for different applications, maybe in the quality control, laboratory analytic, then research and development, process, etc. So see here different fields, maybe chemistry, petrochemistry, pharma, then agriculture, food, feed, so many different fields we actually support here, or we have different applications in these fields. Now, as a Bruker Optics, see we handle different product lines. So here you can see FTNIR, FTIR, then microscope, Raman, gas analytic system. So in this first line which you see, FTNIR, so there are various models you can see. See this FTNIR systems mainly these are used for proximate analysis. So in any sample, if there are many different parameters which we actually do or make use of different techniques, lab techniques, or maybe HPLC, GC, UV, etc. to carry out that test. So same test we can do with all these FTNIR spectrometers. Hello. So here in the second line, if you see, there are FTIR spectrometers. You see various actually models are there. So first one which you see, that is a very small Bruker's, very small compact FTIR spectrometer. So this works, in a mid-air region, and you can do many basic, applications, or you can use for basic research purpose. Okay, so there are many accessories are available with this system. So we can attach these accessories, and then we can do the measurement like transmission, ATR, then reflection, or maybe front reflection accessories. So many accessories are available with this spectrometer. And then this is another FTIR spectrometer, which is a high-end FTIR system, we can say. So in this, there are different features available, like you can cover different spectral ranges like mid-IR, far-IR, near-IR, visible, etc. And also, the hyphenation of different technique is possible with this. So we can connect or attach techniques like microscopy, or maybe Raman module, or external sample compartment. So likewise, here the scope of this instrument is bigger. And then also, if you see certain specification wise, like resolution, so there are different options, or maybe signal to noise ratio, very high signal to noise ratio available with this system. So actually speaking, very different research grade applications. Maybe you can work in the electrochemistry, protein analysis, detector characterization, source characterization. So many applications you can perform using this system. And then this is another model which is actually called vacuum FTIR spectrometer. So here in this entire optics and sample compartment is under vacuum. Okay, so here this system again it is used for very high-end applications. So this system may be available in different research organizations like IITs and BSc or maybe IGCA. So many different institutes you find this vacuum spectrometer. I think IIT Delhi. Yeah.
Chemical engineering department is already having one vacuum FTIR.
Right. So then, applications, as the system is under vacuum, so see this is free from all moisture or maybe air, CO2, gases, etc. So there is nothing actually interference from this atmosphere that way. So whatever you get the peaks, which are actually from your sample. So even very small, signal or maybe signature is there, then you can, easily detect for any sample. Hello. It's fine. Then see, these are actually three models we have shown, but there is very high-end system is also available with Bruker. That is IFS 125 FTIR spectrometer. This comes with very high resolution, that is 0.0005 centimeter inverse. So this kind of systems are available in I think this one physical research lab, then DARC, etc. They are using this such kind of system for atmospheric research. So this I wanted to tell that see Bruker has very very high-end systems which nobody offers. That way I can say. Then in this microscopy again, if you see, there are various kind of different models, mainly two types: FTIR microscopy systems, and then this is a Raman microscopy system. So again, in FTIR microscopy system, there are two different models. One, the FTIR spectrometer we can attach to microscopy module. That is one option, and then another option is this is a standalone second this picture which you see there, or this system which is there already in front of you. That is a standalone FTIR microscopy system. So you don't need any FTIR spectrometer separately, okay, to connect, or a hyphenation is not required here in this system. So this is a standalone FTIR microscopy system. There are many applications we'll see later. And this one, the third picture which you see, that is a Raman microscopy system. So it comes again with all camera, different laser options like 480, 532, 633, then 785. Also we can go with 1064 nanometer laser. So different options available with this. And then fourth line which you see, that is actually our Raman spectrometers. So first photo which you see, that is a FT Raman spectrometer. Of course, this is again a standalone FT Raman. So many applications you can do using 1064 nanometer laser. And then there are another photo which you see, that is actually a module which we can attach to existing FTIR spectrometer. And then the last one which you see, that is a Raman spectrometer. It comes with again two lasers. So this is also very important, maybe a tool for identification of or verification of different compounds. And then last one, gas analytics. So in this again, see this first photo which you see, or the first system, that is actually a gas analytic system which we can use in your lab for maybe measurement of trace gases like in ppm level, etc. So here the system, it comes with 400 gas data. So any gas component you can measure in ppm level or so. Okay, so this is advantage of this system. And then other two.
When we couple it with thermo system,
This one.
yeah,
No, this is actually, sir, independent, only, I mean, the FTIR system for gas analysis only.
evolved gas analyzer, not evolved gas analyzer.
Evolved gas analyzer, actually, this FTIR we have to connect. Okay, so EGA coupling and all, no? So here we can do it. But this is a specifically, dedicated gas analytic system. So those who wants to, study gas level, maybe the ppm level or less than ppm level, they can do it. So this is an automatic system where you can, just fill a gas in the gas cell, and then whatever gas components are there, that you can analyze, automatically, means through the software. You have to just select different gases which you want to actually see the data. So software will give the quantitative data for your gas components that way. And then the second one which you see, this is actually called remote sensing system. Okay, so this kind of systems we can keep, for example, here, and then we can record the data from say 500 meters to 10 kilometer distance. So whatever maybe gases are getting released at 10 kilometer distance, also we can analyze using this system. So maybe there are many gas explosions, or maybe sometimes in the industrial area, different gases are getting released. So there, if you want to see which gases are releasing and what is the concentration, etc. So from the long distance, you can do this measurement.
Toxic chemicals.
Yeah, yeah. Sometimes there is a fire in some area, so there again some poisonous gases are getting released, or maybe some events are going on. Sometimes some games, or maybe different international conferences and all. So that time also you can put this system at some distance and then see what exactly maybe some toxic gases or something is getting released. Okay? So safety point of view, this is very important. And also these gases, these systems we can use for greenhouse gas, I mean environmental research purpose. Many people are using for measuring greenhouse gases and all. So likewise, there are many actually the systems available in this. Three models only we have shown, but there are different models also available in this. So even you can do systems which you can use for different side applications. Well, then if you will come to again microscopy specifically system. So here in Bruker actually you see there are various microscopy models available. So this is some IR light is absorbed by the sample, and most of the IR light is transmitted to the through the sample, which is then brought to the detector, and then finally it is converted to FTIR spectrum by applying Fourier transformation. So this is a simple actually principle of working of this technique. Okay? Now the FTIR spectrum which we create, that is it is called a fingerprint of that particular molecule or compound. So here, see, that's why we call, or we take as a reference of this spectrum. We take as a reference, and we can then use for identification of any unknown samples or compounds. Now, if you see here, when this FTIR spectroscopy, when we attach to microscopy, okay, then the scope of this instrument will increase. So we can use this technique for identification of microscopic sample, means very small size samples, micron level samples, right? So this is very important from analysis point of view. So now, so any good lab, good analytical lab needs actually best tools, right? Right. Then only we can perform your maybe work or any analysis, etc. So here we introduce blue moss to FTIR microscopy system. You can see here this system, it is actually a standalone FTIR microscopy system. So standalone, I already told. So there is no separate FTIR is required. So this box, if you see, it contains two techniques. One is spectroscopy, another one is microscopy. Right? So very convenient system for your analysis. So you can see here the system actually it is also we call imaging system. I'll tell you why we call it imaging system. So in this FTIR microscopy, if you see this, if you see the line, it is increasing because if you see here in the first one, this model, if you see, this is actually only for maybe very easy to point and shoot that way. It's just single point or multiple point you can choose, and then you can record the spectrum that way. But if you see another model, which is called luminous imaging system. So this system, it comes with a focal plane array detector, and here we can do measurement or mapping very fast. So we call imaging system. And then now the next actually model has released this year itself. So this is called LUMOS 2 ILIM system, means laser imaging system. So even you can get laser imaging system with this particular model, right? So if you see analysis wise, here you will get or you need a little bit more time because single point we are measuring. Here we measure 32 by 32 pixel at a time. But here if you see, this is very fast actually. So at a time you can measure area like 4.5 millimeter square area in 1 second. Okay, so that way it's really very fast. Even very big sample is there, within few minutes you can complete. So that way it is very fast. So that way, and you can see these different models we have, grouped is in a coming way for your important features of this system. You can see here, this system is actually speaking very compact system. So very small space is required here. So just plug and play like system. So means just you have to power it on, and then you can start using. Here, no liquid nitrogen is required. Means see the detector which is available here, standard detector which doesn't require liquid nitrogen for cooling. So it is called thermoelectrically cooled liquid nitrogen detector is available with this for microscopic measurement. Then the system is completely motorized or automated, we can say. And in this, if you see the stage and the objective distance, it's around 40 mm distance is there. So period sample also we can place like such sample, and you can do the measurements. Then if you see this stage, it's open from all sides. So it is very easy actually as access for this placing the sample on the stage. And then this system actually it comes with video guided visa. So just you have to follow certain steps and then you can reach final measurement and then evaluation that way. Here visual resolution, if you see, we can see in submicron range your any sample, right? Then here lifetime of the main components which are used in this system are like laser or maybe source. It comes with more 5 years or even 10 years warranty. So there is no actual consumables required or lifetime. If you see, it's very long actually. So source also maybe after 5 years you need to change that way. So till 5 years there is no any maybe maintenance is required for this system. Now very important point or important feature here, this system is it is coming with high humidity optics, that is zinc solenoid optics, and that's why we can take this system anywhere actually. Otherwise it's really very difficult to move this such kind of system from one place to another place, right? So we have brought this system from Mumbai office. So here you can see, because of zinc solenoid optics, which is thinner to atmospheric humidity and all, we can easily carry this system from one place to other place. Then as I told, it's very small footprint, so we can take it also maybe wherever you want, or maybe very less in the space we can place this system. Power consumption is normal power consumption. Power is required for this system, and this system is again compliance with all regulatory requirement like CFR compliance or maybe GMP, GLP, whatever regulations are there, that it will fulfill, right? Well, now along with this or with this system, there are different analytical or measurement modes are available, like transmission. You can use transmission measurement here. Also reflection is possible, normal or a specular reflection which we call. And then third one is ATR, attenuated total reflected. So all the modes are available, and the fourth mode is called imaging. So that is also possible when you go for that corresponding detector, okay, like focal plane array detector. So all modes are available in this system. Now if you see this, this is again a unique feature of this system. The ATR, you see here objective, which is motorized. So during analysis only it will come out, and then it will touch to sample. After analysis again it will go back and it will sit in the objective. So here this is really very important, very safe actually. So there is no any chance of getting this crystal damage, right? So this is a very important feature for this system. You can see here, this way it will come out when you give measurement command. It will touch to the sample, again it will go back that way. Now distance, already I have told, a large distance is there between the stage and then objective. So bigger samples you can keep here and do the measurement. So this is again a unique point. Many other system, if you see in the market, very small distance is there between the sample stage and the objective. So you cannot keep such kind of samples. You cannot place on the stage and do the measurement, or analysis cannot be done. Then you can see here, this system, as I have already told, this comes with video guided measurement. So few steps only you have to follow. So first thing, you just need to place sample on the stage. You can see that stage. So here you have to just place the sample. Then you have to focus it and collect or see the visible image. You have to capture the image. Then you can perform the background, and then you have to just mark the position where you want to record the spectrum that way. So it's really when you see the clear image, you can mark the position wherever you want to take the spectrum, and then you can go for actual measurement. And once you get the data, right, it's really very easy to identify that material using different libraries, right? So this way, if you see, it's very simple, very convenient to use this system. So I can tell you this system, actually it is research purpose people are using, but even this operation and then convenience, if you see, people are using this system in the quality control department also.
So it is equipped with the library.
Yes, actually by default, libraries are available, but few libraries, dedicated libraries are like polymer library, maybe chemical libraries, and pharma library, packaging material, forensic samples. So many other libraries are there that you have to tell us when you actually buy the system.
Some people used to diagnose the kidney stones.
Yeah. So
That library is also there.
kidney stone library is also available, but these libraries are, additionally you have to add actually when you choose the configuration library. Then here again a very important point from this microscopy point of view, that the detector which you want to choose, okay, so here if you choose the right detector, then only you will get the right result or right measurement you can do. Okay, so in this case, standard in this instrument, standard detector available is called TNCT detector, that is thermoelectrically cooled NCT detector. That means no liquid nitrogen is required for measurement. Then with even this TNC detector, you can get best sensitivity and broad range of applications you can perform with this detector. Now, next one is liquid nitrogen cooled MCT detector, right? LN2 MCT. So here we need liquid nitrogen for cooling the detector, and then only you can measure the data that it is. But here with this detector we can get optimum sensitivity. So even small some samples or small particles are there, you can easily do it. I'll tell you the difference between these two detectors, TNCT and LNNCT. TNCT, you can go measurement point, if you see, you can go till 10 micron size, okay? 10 micrometer size sample or particle you can measure with this. But still, if you want to go down, then you have to use this liquid nitrogen cooled NC detector. So here we give the limit 5 micrometer of particle size you can cover, but actually speaking you can go still lower, that is 3 micron, 2 micron also. But in the specification we mention here 5 micrometer. So for highest sensitivity you can go this with liquid nitrogen cooled NC detector. Now again here one more detector available, that is called focal plane array detector, right? If you want to do very fast measurement, then focal plane array detector is required. So with this LN to MCT or maybe TMCT, we go one by one, okay? But here fast measurement is possible. So that is the only difference here. Now here one more detector is available, that is called TLA-TGS detector. Of course, this detector we don't recommend for microscopic system or microscopic measurement, because this is used for your normal regular bulk sample routine FTIR which you use. In that this is used. So sensitivity of this is very poor comparative to this MCT detector. So if you see here, so for particular size sample, if you see this is with LNMCT or MC detector, and then this is with DTGS detector. Again, the particle size, if you consider for maybe 100 micron. If you see very noisy spectra, you will get, so you will not come to know whether it is noise or signal for your samples that way. So we don't recommend this DTGS detector. In this case, there are 3 detectors you can install in this system. At a time, 3 detectors. So you either FTMCT plus LMMCT or FPL or other combination. So 3 detectors you can keep. That means now all possibilities are possible with this system. So some people they go with TMCT, also additional liquid nitrogen fluorescence, or TMCT plus focal plane array detector. So there is no then limitation we use. Whether you have maybe liquid nitrogen with you or it is not, then also you can go for measurement that way. So if you see here specifically in liquid nitrogen or MC detector also, there are different options like mid band, wide band, etc. If you want to cover broader range from say 450 centimeter inverse and above, then broad range LNMCT is there. Otherwise, normal case it is a mid band, that is from 600 onwards you can do, right? And focal plane array detector, it comes with 32 by 32 pixel. Okay, so 1 pixel you can consider as a 5 micron for transmission and reflection, and for ATR you can go still 1.25 micron size, right? So this is a pixel if you consider, or the particle size, how much we go for measurement, that is there. And then DLTGS detector, of course, it's again a single element detector. And in this, you can see here, spectral resolution is 2 centimeter as a standard, but of course we can go higher, 0.8 centimeter inverse, right? So this is also there, and then signal to noise ratio and all. This is the most or best signal to noise ratio we give, which nobody actually else gives in the market. Okay. Well, now along with this, there are various holders are available with this system. So maybe you can see here, this is called micro-wise holder. So for holding of uneven odd-shaped samples, you can do. Then this is a filter holder. This is again for very brittle shaped samples are there, then that we can hold that way. Okay? And
this filter is for microplastic.
Microplastic, yes. So specifically for microplastic, you have to go for that holder. Yeah. Now this is again a separate accessory, or it is called temperature controlled stage. So Lincoln stage is given, so we can even either heat or cool the sample in this temperature range, right? So this is also important for some people. So everything it's required for your measurement purpose is available with this system. So in this case, if you see here, everything is motorized, like ATR crystal is motorized, then aperture is motorized, then condenser is motorized, polarizer is motorized, analyzer is motorized, XYZ stage is motorized, changing from visible to IR or IR to visible is also motorized. So in fact, everything is motorized in this system, right? So that is the advantage of this system. Now, along with this system, okay, this is a microscopy system which you see, which is called macro unit. So for your regular samples, bulk samples which you do with your routine FTIR, so same samples we can do with this. And now here we can also change various accessories like ATR, transmission, gas cell, or maybe front reflection accessory, liquid or here with multi-bounce, ATR accessories. So many accessories are available with this. With that we can do your routine measurement along with the this microscopy. So whenever the microscopic sample is there, you have to use this, or for routine sample, you can do it here itself. Right? So again, there is no limitation from sample measurement point of view.
What is the full form of drift?
Drift is diffuse reflectance infrared. So here, if you see the advantages of these techniques or benefits, very easy to use, then and applicable by almost everybody this system. Then if you see it gives reliable and reproducible results or measurements. You can see here sample preparation wise very little or no sample preparation is required. Then the system can be used for all solid, liquids, paste, films, etc. Then analysis time is also very short actually, within few maybe seconds or within a minute you can identify any sample. Consumable wise, no consumables are here required, and actually speaking, no any chemicals or maybe harmful radiations are used in this system, so it is very safe system, non-toxic actually. System where during analysis or after analysis, maybe sample can be recovered again back, so that is again advantage. This is a non-destructive technique. And as see here, life or time of this spectrometer, if you consider, then like all main components like interferometer, then laser, it comes with 10 years warranty, source comes with 5 years warranty. So again, lifetime, if you see, it's longer and no consumables are required for this system. Right? So this is about this system. Maybe if any doubt, anything is there, you can ask.
So we can do quantification as well.
Actually, sir, microscopy. So very small concentration, or maybe sample. We just focus and do the measurement. So mainly, this will be for qualitative analysis. Quantitative analysis means we have to representative sample should be actually we should get the data or a spectra. Here we are focusing very small particle, okay, of 5 micron, 10 micron. So quantitative analysis here actually is not the purpose. That way. You want to do suppose quantitative analysis, then that macro unit there you can do it. Not a problem. Yes. Now if you see typical actually applications for this microscopy system, then you can see you can use this system for identification of different particles, maybe of polymers or particles on the filter, maybe in the pharmaceutical formulation. Sometimes in the market complaint some particles are suspended in the solution or maybe in the tablet, some color is there, some particles are seen actually in the tablet or on the tablet. So this kind of analysis you can do. Optical components, you can maybe some particles or contamination on the optical components that we can do. You can even use for measurement or study the defects and contamination. Like, right? Then if you see, you can use this for surface analysis purpose. Maybe sometimes coating is there on the metallic surfaces or metallic substrate that you can study. Ink on the paper, right? Some organic layers on the surface. So likewise, there are many applications in the surface analysis that we can see in the later slides. Now, different material like say polyethylene, polypropylene, then polyamide, so many different layers you will find in the polymer packaging materials. Then you can see paint chips or the varnishes again there are different layers of it that you can study. Forensic is another actually department where you can study different samples, fibers, maybe whatever material is found at the crime scene or a crime site that you can study and you can go for reverse engineering purpose, right? So if you see again, very important layer which acts as a oxygen barrier. So most of the time people wants to confirm this whether this material is there in the polymer packaging film or not. So this is again a challenge. So again, when you scan this entire packaging film, then you can see here in the chemical image you can see different compounds are shown with different colors. So this green one is PET, this this is a polyamide. Then you can see the purple one is polyethylene, and that if you see that blue one is a EVOH material, right? So this way, this is a confirmatory technique we can see for such kind of this, samples. This is another example of polyethylene pellet. There is some contamination or defect is seen. So again, when you see under microscope, easily you can see that, and once you see that, you can mark it and go for measurement. So it's really easy that way. You can see the spectra for matrix and then contamination. So two spectra are not matching with each other. So this material is again a defect. So once you go for a library search, then it will identify. See, it is identified as a polyester. So there is a contamination of polyester and polyethylene that way. This is again defect in the transparent film. So if you take spectra at different positions, then you can see different spectra or spectral pattern is seen for different positions. So again, here you can easily identify different materials. Now in compounding polymers, again you can see different fillers or materials being mix it. So you have to just see how the spray maybe distribution of each different material is. So again, here the imaging or the mapping you can do it, and then chemical image when you see, you will see the different material with different colors, right? Then again, surface, if you see, some surface people they see for contamination. So this is a polymer surface with some contamination. So easily you see this contamination under microscope, and just you have to mark that position where you want to record the spectrum. See here. So this spectrum, once you get, as I told, library research has identified as a polycarbonate, right? So likewise, so many actual examples can be shown here. Now you see, for polymer purpose, this is a very rich library is available, KIMW library. So it comes with very new polymers, fillers, then additives, so many things. Okay. Then this is an example of packaging film. So just any packaging film, you have to just cut it, and then using this holder, just keep vertically, they take thin section with the sharp blade and place under microscope. So you can see different layers are there, and then each layer you can see how much thickness of each layer. Then also you can mark each layer and go for measurement, right? So in this there are like some resin, some wax, or maybe sometimes paint layer. So likewise you can see different layers in this. Then also if you see car varnish. So this is again in forensic, these people they can use. Biological samples, so, or biological tissues, you can analyze. Maybe just you have to take a tissue, spray it on the this gold plate or maybe some aluminum coated plate, and then you can study, the distribution of or the spread of different like fatty acids, or maybe sometimes protein, denatured protein, etc. So this is again an important technique for such samples. This is an example of electronic circuit. So in electronic circuit also there are sometimes contamination or particles. Some contamination particle is there on the metallic chip. So that you can also see under microscope, and then you can do the measurement. So here you can see there is something is seen, right? So dirt or maybe something. So just we can focus on that, record the spectrum, and then you can see what exactly it is. So spectrum for this blue dot you see, it is like this. So you can just easily identify what it is. So it is identified as something like maybe material like um, biological material, maybe skin or something like protein, wool, etc. So here, this industry, if you see electronics industry and all, many people, I'll take the examples also. Foxconn, who actually manufacture this iPhone and all, they are using this system. Apple, they are using this system. Pegatron is also in the similar way. Okay, those who are in the electronics, so they are using multiple system. Samsung is using this system. Okay, for such application only. So.